Our problem states, sand is falling down from a table onto the ground to form a conical pyramid. Every 30 seconds, the height increases by 5 inches, while the volume increases by 15 cubic inches every 15 seconds. When the height is 25 inches and the volume is 75 pi cubic inches, at what rate is the radius of the base changing every minute? So when we first approach this problem, we want to figure out what we already know and what we're trying to find. Let's underline some of the things we already know. So we know the sand is falling down from the table onto the ground. We also know it forms a conical pyramid. So the height increases by 5 inches every 30 seconds, and the volume increases by 15 cubic inches every 15 seconds. Next, we know the height is 25 inches at the moment, and the volume is 75 pi cubic inches at the moment. So that's what we know. Next, what we're trying to find is the rate the radius of the base changes every minute. Now that we underlined everything we already know and what we're trying to find, let's write this out to make it more clear. We know that we are going to need the volume formula for this problem. So we know that the volume of a conical pyramid, or a cone, is 1/3 pi r squared times the height. We also know dH/dt, or the derivative of the height with respect to time. So we know that dH/dt is 5 inches per every 30 seconds. We also know that dV over dt, or the derivative of the volume with respect to time, is 15 cubic inches for every 15 seconds. We know the height is 25 inches, and the volume is 75 pi cubic inches. Know these variables. What are we trying to find? We are trying to find the rate of the change of the radius of the base every single minute. This would be dr dt. So question mark for dr dt, because that's what we're trying to find. Because we're trying to find this in minutes as our unit, we need to convert seconds into minutes. So first is dH over dt. dH/dt is 5 inches for every 30 seconds. Now, since 30 seconds is half a minute, we can multiply everything by 2, so minutes will be the unit. So this would result in 10 inches per minute. So dH/dt is 10 inches per minute. Next, we also want to find dV/dt in terms of minutes. So since it's 15 inches cubed for every 15 seconds, we know that 15 seconds is 1/4 of a minute. Here we will multiply everything by 4, so then this would result in 60 inches cubed per minute. Now that we know what we know, what do we need to find? So there are two things we need to find. One is obviously dr dt, as previously stated, but we need to find the radius first, so then we can find dr dt. First thing we're going to do is find the radius of the base of the conical pyramid. To do this, we will use the volume formula, as we already have the volume and the height, so we will just plug these values in so we can find the value of the radius, or r. Plugging in the values, the new equation would be 75 pi equals 1/3 pi r squared times 25. Then we want to divide both sides by 25, so we can remove 25 from the right hand side of the equation. After doing this, the new result would be 3 pi equals 1/3 pi r squared. Next, we want to divide both sides by pi, so we can remove pi from the right hand side of the equation as well. The new result would equal 3 equals 1/3 r squared. Next, to get r by itself, we need to divide both sides by 1/3, and this would result in r squared equals 9. Next, you want to square root both sides so you can find r, and this will result in 3 and -3. However, since the radius cannot be negative, we will disregard -3, which means the radius of the base of the conical pyramid formed by sand is 3 inches. Now that we know the radius, we want to find dr dt. Now, dr dt is the rate of change of the radius of the base for every minute in our case. To find dr dt, we will again use the volume formula, except this time we will take the derivatives of both sides so we can solve for dr dt. For the left side, the derivative would be d over dt times v, or dv dt. On the right side, it would be the derivative of the whole thing, so it would be the derivative of 1/3 pi r squared times the height. However, since there are two variables on the right side and they're being multiplied by each other, we would have to use the product rule. So first, you would isolate both of these terms. the first term would be 1/3 pi r squared, and the second term would be h. So let us create a little table to show this. On the left, top left, we have 1/3 pi r squared. So we would bring the 2 down, so it would be 2/3 pi times r. We'll subtract this exponent, so just r to the 1, which is just r, times the derivative of r with respect to time. On the left, the derivative of h is just dh dt. You know that we have to add the terms together. The new equation would be dv over dt equals 2/3 pi r times the height times dr dt plus 1/3 pi r squared times dh dt. Now again, let us plug in the values that we know. So we'll plug these values in to have a new equation of 60 equals 2/3 pi times 3 times 25 times dr dt plus 1/3 pi times 3 squared times 10. So now we want to simplify the equation. First, we would simplify the first term on the right hand side. So if you multiply 2/3 by 3, you would get 6/3 or 2. And then you would multiply 2 by 25 to result in 50. Next, you would combine everything. It would be 50 pi dr dt. Next, you want to simplify the second part of the right side, which would be, so you want to multiply 10 by 1/3, and this will give you 10/3. After that, you want to multiply 10/3 by 9, which would give you 90/3 or 30 pi. So the new equation would be 60 equals 50 pi dr dt plus 30 pi. Next, you want to get dr dt by itself. To do this, you would first subtract 30 pi from each side to remove 30 from the right hand side of the equation. This will result in 60 minus 30 pi equals 50 pi times dr dt. Next, you would divide both sides by 50 pi. This would result in 60 minus 30 pi over 50 pi equals dr dt. Now, this is a good answer, but it's not the best. We can simplify even more. Next, we want to simplify. We can factor out a 10 from both 60 minus 30 pi and 10 from 50 pi. So to do this, obviously, we just factor out a 10. This result would be 10 multiplied by, in parentheses, 6 minus 3 pi, close parentheses, over 10 multiplied by 5 pi. Because both the numerator and denominator have a 10, we'll cancel the 10s out. But we can simplify this even more. So you can separate the terms. So it's dr dt equals 6/5 pi minus 3 pi over 5 pi. Now that they're separate terms, you can cancel out the pi's in the 3 pi over 5 pi. We're trying to find the rate of change of the radius of the base of the conical pyramid every minute. So as this calculation is shown, we have done all the calculations in minutes after converting them from seconds to minutes. So the final answer, the rate of change of the radius of the base for every minute is 6/5 pi minus 3/5 inches per minute.